All right, everyone. Hi. Welcome AP Calculus to this early class time, 10 a.m. here. Welcome. All right. Today I'm a French fry, but anyways. Oh, okay. I feel like I asked this question of my advisory, so it's okay if you use the same character. I feel like um every time I feel like every day I want to choose a different character though. So our check-in today is share your favorite Disney character to the best that you can in the chat for us. And then that will be our check-in. And it's okay if you're like, well, I don't have a favorite. That's okay. Or if you have many favorites, no problem. All right. I see the chat getting populated. Ooh, we got some good ones. Awesome. We got Ariel, yeah, that one's good. Oh, Stitch, yeah, Stitch is. I was actually like really obsessed with that, and I was like in middle school when that came out. So, yes, Belle. Oh, we got another Stitch. That's awesome. Eeyore, Dory. Oh, the from the fish, right? I think Flynn Rider. I don't think I know Flynn Rider. And then Wally. Awesome. Yeah. So, oh my gosh, it was hard for me to choose. I know last time I said Pocahontas, or I also even thought Ariel or Belle. Today though, I'm thinking for today, just because I watched Lion King yesterday, Simba. So today it's Simba. Oh, we got Goofy. I didn't really grow up with the Mickey Mouse, but I'm pretty sure pretty cool. That one's a good one. Miss Calloway. I don't know that one. And then Stitch. Yeah, a lot of Stitch fans. That's awesome. I remember when I was younger, the first movie made me cry. All right, so let's see. We still gonna answer the check-in. Go ahead. This is who we're missing today. I mean, we some are excused. So I'm not gonna say the excused missing, but we're missing or I have marked absent Evie and James. So if we're friends with either Evie or James, please let them know to come into class. Let me just double check that though. Hold on. No, wait. No. Evie, James, and Grecia. Sorry. Also Grecia. So that's who we're missing. I'm hoping they could come in here today for our deep learnings that we're going to be doing. All right, cool. Thank you so much, y'all, for sharing. Let us move on to today's agenda. Let's take a look. We're going to do some learning here. So we just had our attendance check. Again, annotative notes slash interactive usually means you're following along with me with a copy of the slides. Of course, you're free if you want to write stuff down. That's totally up to you if it helps you. Um, we're going to be talking about critical points and hopefully get to the beginning of the something called the first derivative test. But if we don't get to it, that's okay. Don't worry about it. My intentions are that I'm finishing up that big ideas packet and I actually want to get it to y'all like soon. Like, as in, I want to make it like the next asynchronous assignment where you, because I think it's like the earlier we get the whole big ideas, the earlier you get to interact with it and kind of like look forward where all this is going and so forth. So that's what's the plan. So asynchronous number one has been posted since the beginning of this module. Again, I've cut down the async for this week because we just started. So async number one was posted. That one is due tonight, today, and it is straightforward review, Khan Academy review of basic derivative rule, the power rule. Um, and again, it's accessible. So even if you forgot how to do it, you could click get hints and it will walk you step by step. Welcome, welcome to those that just came in. Make sure I update. Yeah, James, you're here, right? Nope. Yeah, you're here. James, I got you. So we're just missing Evie and Grecia. Again, it'd be great if I could get some help, get them in. All right. All right, let's get to it. So, boom. So remember, actually, so I'm reviewing with you. This was the essential question I asked you all last time. What are critical points and how can they help us? We're still going to be thinking about this essential question. So today we're still thinking about that until the end of when we actually discuss what they are. And then last time I gave you all a Padlet with a picture of this, and I asked you to kind of like guess or like make an educated guess based on the visual on what you think critical points are. And again, in math, visuals can be super powerful. Like it's very hard to make sense of math when it's all abstract. I'm gonna go ahead and put the Padlet back in just so you could kind of review what was it that you said last time when you wrote like what you thought the critical points were. So I'm gonna open up the Padlet with you. I also started numbering them too, so it's more organized, and that way I'm like we're on the 6th or the 7th. So again, I just feel like it's organized to keep it all there so y'all can go back and access it. So again, we had the prompt, you all wrote down your initial thoughts, and then after we got a little bit of exposure on what critical points were on the 5th column there, you all went ahead and put your current understandings on what they are and how they could help us. So feel free to look through this and kind of review what y'all were saying before. So this is just to make sure that we're re-engaging back into this. And again, you still have time to put in your thoughts. If you're missing your credit for this day, just let me know, send me an email, and I'm happy to like give back that credit 100%. Okay, and then maybe you all can preview what's gonna come up next, right, in our prompts, but I'm gonna go ahead and take us back to the slide. This was so y'all can refresh yourselves on critical points and what we did. Um, so again, I went over what critical points were. There were the derivative is 0 or undefined, and there's different case scenarios that happen or different possibilities. And I'm on the 7th slide, by the way, everyone. So actually, let me pause here so that you all have time to go to Google Classroom and open up your old copy. My bad, I should have actually made sure. So I barely just put this. So this is quarter 3, day 3. So you could make your own copy if you're planning to make your little annotations. Again, there's different ways you can annotate your slides. You can make a comment using this comment box thingy, or you could use the little notes section down here. You could like type out little bullet points of your notes. So those are the different ways you can take notes so you don't forget things as we're going over stuff. But again, you are free to also copy stuff down if it helps you. So let me give you a moment to make your copy. Yeah, so great. I have a clarifying question right now. You said we will commonly only see A, right? Yes. So for the most part, for this unit, we only have enough module time to talk about this case, and perhaps we'll see something like this, where it's like it looks like it's a max or min because it flattens out around there, but it's actually not a max or min. And you'll see how we can test it. It's actually the first derivative test is going to lead us to check whether we have something like a max or min or something like this at the bottom where it looks like it's flattening out but actually doesn't. So yes, these ones here, we won't get a chance to really investigate unless you investigate it for yourself. But basically these happen when your derivative is undefined. But we're mostly going to look at when the derivative is 0. Great question. So that's just, if you see it on the AP exam, you'll know like, oh, okay, this is that thing. All right, I'm hoping everyone got to the slides, made their copy, or is following along on this one. You might want to make a copy once we hit to the actual math and steps like we're going to in a second. So I'm going to go ahead and transition us into slide number 8. So great. We talked about the importance and the value of critical points. Now comes the technical part. How do we actually find critical points? Dun, dun, dun. So there's steps. Here they are. I tried my best to kind of delineate each step. Step one, take the derivative of the function. This is the first derivative. So just take the basic derivative. Step two, you're going to set the derivative equal to 0. Now, you want to even think about why this makes sense. Because remember, when we set the derivative equal to 0, that means you're going to have a max or min, or something that looks like this, which I pointed out when, so when the derivative is 0, that means that the graph is kind of like flattening out. So it's a possibility that it's a max or a possibility that we have a min. So that's why this step is important, and that's how we're going to use it in our test. So I just want to make sure I include the y. We have to set the derivative equal to 0 to figure out if we have a max or min. Then step 3 is we're going to solve for x, usually by factoring. Sometimes though, it's straightforward and we don't get to factor. We're going to take a look at some of that today. After you're done, right, factoring and you've solved for the x values where these critical points are, you're going to take those x values, you're going to plug it into your original function, and those are the so-called critical points. And yes, I've seen questions on the AP exam like, what are the critical points for this function? And if things are still on Zoom and you're online, you're able to use like Google and other resources to kind of help you out. It used to be where you had to like really like, when it was, the traditional way of doing the AP exam, you had like 0 notes with you, just a calculator. And so it should be nicer, I'm hoping, if it's still like that, where you could kind of like use all your resources that you have in Access. But let me just pause to see if anyone has questions about our steps before I actually do a walkthrough of an example of how to find these special points, the critical points. Okay, if there's no questions, let's get on with it. Here we go. Example 1. So as I'm going through the steps, like feel free to annotate, if there's a certain part that you have a question about the step or something so that you can, ask once I pause and ask, like, does anyone have questions or clarifications? So let's go. So let's pretend we have some basic question like this. Find all critical points of, and this is an interesting function, so f of x equals x to the 4th minus 8x squared. So if you refer back to the steps on the previous slide, step 1 is take the derivative, which should be using the power rule. Step 1. Notice how I put a little mark there to denote that that's my first derivative. So we're just taking the first derivative, and that's the power rule. Bring down the 4, subtract 1. Bring down the 2, subtract 1. You should get this. I see something in the chat. Yeah, that's totally fine. So yeah, somebody was asking, doesn't matter if I take notes in my notebooks and not on the slides. It does not, so don't worry. Basically, I'm just not going to be collecting notes anymore. This is just like, it's for some of you, it's going to be more easier to just directly take notes on the slide. And it just felt kind of like there's no point in me collecting the notes because I kind of was realizing I was just doing something out of custom, I guess, because it's like I got used to checking notes when I was in class, but it might be easier if you already have the notes itself and you just annotate it. But yeah, no problem. You could totally take notes on your paper if it helps you. For some, it might work like that because, math steps, sometimes it does involve, maybe you want to write it down and process as you write. All right, first step, again, make sure if you have any questions to jot it down. Okay, next step, if y'all remember, step 2 was set the derivative equal to 0. So all I did was, instead of writing f prime of x, I set that derivative function, all of this, equal to 0. That's step 2 in our process of finding the critical points. Okay, step 3 is going to be the part that perhaps might be interesting. So the next one is factoring. So some of you remember factoring using the box method. And hold on a second, factoring with box method. Okay, I remember, y'all. I had to look this up now. Forgot how to factor with the box method. I just did a quick Google search. Even though, y'all, I know I taught you this like a lot last year, but I just looked at this like, okay, I looked at the box. I'm like, okay, got it. So I'm gonna show you in a second. Okay, so we're gonna factor with the box method in a second. But what I did first is this strategy. To make your factoring easier, what you could do is factor out the common term. So because 4 goes into both 4 itself and 16, I pulled out a 4. So let me just circle that. I pulled out a 4. Oops. Like, it's kind of like the reverse distribution method. Another thing these two terms have in common is they both have an x that's in common. This one has 1x, this one has 3. So therefore, I can factor out 1x, just an x. So in total, I factored out 4x that was common term to both. So that's what I did in this here step. See if anyone has questions on that. I pulled out 4 and I pulled out x. Okay, wait. Rosa says it's 2. Oh, Rosa, you're saying the answer is 2. Oh, okay. Wait, did I factor this wrong? And then why did you pull out? So basically, when it comes to factoring, you want to pull out the common factors first. And so because x is common to the first term, let me just underline it. So let me address this question. Why did I pull out x? So if I look here, the first term, it has 3 x's. I look here to my second term, it only has 1 x. So therefore, because both of these in common, what they have in common is just 1x. If I pulled out 2x's, I wouldn't be able to because this only has 1x. So I was only able to pull out 1x right here. So that's why I pulled out 1x. And then again, I pulled out 4 because they both have a common multiple of 4. No, yeah, Russell, you're right. So I think 2 is going to be a solution. You're right. So there is like a guess and check kind of process, I believe, that you're doing. You're kind of like mentally plugging in 2 and seeing if it equals 0. That's totally, yes. That's totally awesome. And there's going to be 2 more, says Juan. So let's see. Let me know if I clarified the why we pulled out the x. By the way, y'all, I'm going to also give you a tool here in a second. So if factoring is something that you're a little bit shaky on, I'm going to give you a tool because I don't want factoring to be something that prevents us to engage in our calculus concepts. So just so you know, yes, I love the encouragement there in the chat. Okay, let me just clear this now. Okay, now we need to fully factor this. So we factored out 4x, that's great. But notice that I still have an x squared right here, minus 4. We can still factor that. And how we can factor that is using the box method, if y'all remember from last year. So again, I'm gonna not care about this. I already took this out. I'm just interested now in factoring x squared minus 4. So I did my Google search, and I'm gonna do this on the side. So we're gonna draw a big old box. And maybe this is something you probably would want to write down. I wouldn't know how you could annotate unless you took a screenshot and then add it there to your slide. So how you do the box method is you usually put the first term here. And our first term, because we're only interested in x squared minus 4, it's going to be x squared. And at the bottom goes your c term, which is just going to be minus 4. Now these two boxes right here, they have to add up to 0 because the middle term is 0. There's nothing in the middle. Usually what we have is something like this. We have ax squared plus bx. So usually there's a middle term called bx. And then we have plus c. But if you look here, we don't have a b. We don't have a term that has an x next to it. So we're just kind of like treating this as if it were 0. So these two numbers have to add up to 0. So I'm just going to put like a little. And this is a review of box method. Again, you're going to see I'm going to give a tool for those who are a little bit shaky on the factoring. Okay, so what are two numbers that multiply to give me -4, but add up to give me 0? Two numbers that multiply. I see some stuff in the chat to give me -4 and add to get me 0. And that's how we're going to fill in those two remaining boxes. Yeah, Rosa, that's one of them, x minus 2. And then Edgar put -2 times 2 is -4. And then -2 plus 2 is 0. So what you wrote, Edgar, I think that's spot on. So we're going to go ahead and put those there in the box. And maybe I'll put the -1 here. And then usually these ones, right, because they're supposed to correspond to the b term, they would have an x, right? And how it works when it comes to actually writing out the full factors is you pull out the common term now from each. If you remember this, so maybe I'll use a different color now. I'll use purple. So 2x and -4. A common multiple between these two numbers is simply 2. So I pulled out 2 from these. So I'm looking at this column. Common multiple. And usually I'm going to say this is a +2 because the 2 is next to a positive box down here. It's next to a positive 2x. Now, if I look here, now for this second part, between x squared and -2x, a common term, a common multiple I can pull out is simply just x. So we have one factor. See, Rosa? Oh, wait, you're almost, actually, Rosa, you got x minus 2. Maybe that's one of them. Okay, now we're not done. We only have one factored form. We got to now do sideways. So now this way. So x squared and 2x, let's pull out the common factor. The only common factor we got is x. No, I think, Rosa, you're good. I think we're going to get x minus 2 here. And then we look down here. And to be honest, I'm not going to care about the minus signs. I'm just going to say between 2x and 4, a common multiple is 2. And I'm going to put a minus simply for the fact that this 2 is next to a box that has a minus. That's all. Boom. So the factored form for this part right here, fully factored, is going to be x plus 2 times x minus 2. So that's going to be that second part fully factored. So then that's going to be the next step. So again, we're still in step 3. We're still just trying to factor this. And there you go. You see that this got factored to that due to the box method or due to any method that you're comfortable with factoring. Fully factoring a function helps us get all the zeros, kind of like Juan said in the chat, right? We don't just want 1 0, we want all of them. And it looks like this has 3. Why do I know it's 3? Because we have 3 separate multiples. three separate terms that are multiplied with each other. So after this step, we're going to go ahead and solve for x. And if you go back to the steps, solve for x, I don't know if that's the fourth one. Yeah, fully factor, and step 4 is solve for x. And that's going to be a critical number. And then the fifth step was we take that number and we plug it back into the original. Double check me on that. All right, we're going to solve now for x. So I put, we're going to solve for all x solutions. So I still haven't solved yet. How we solve is because all of these are equal to 0. That means we could set each multiple equal to 0, and it's going to give us a solution. Set each multiple equal to 0. That's how we solve for x here when you have a factored form. So I have 4x is equal to 0, x minus 2 is equal to 0, and x plus 2 is equal to 0. Now, all we have to do is solve for x for each one of these. So for this one, all I got to do is divide by 4 both sides to solve for x. 4 divided by 4 is 1. So x is going to just be equal to 0 in this case, because 0 on top is fine. 0 divided by 4 will give us 0. This one, all we got to do is add 2 to both sides. And minus 2 plus 2 cancels out. So we have x equals positive 2 here. So I think that, see how, Russell, you got that one solution. That's awesome. For this one, we got to, so again, remember, you do the opposite. This one, you got to subtract 2. So there are our full 3 solutions here. There you go. And let me just pause there because I just did a bunch. Yes, Sophia. Awesome. You got it. So those are your full 3 solutions. And these 3 numbers, these x values, they have a specific name. They're not called critical points yet, right? We're almost done. I think we now need to go to the last step. Once we solve for x, we take each of those x values, plug it into the original, and then we'll have our full critical points. These do have a special name though. Instead of critical points, they're called critical numbers. So there's a distinction. These are called critical numbers, and they're super important. Yes, I love this. It's such a positive class. Okay, so we got our critical numbers. Now let's do our last step. Again, if you go back to the prior slide, you'll see the last step is we got to take each one of these critical numbers and plug them into our original. Let me circle the original, so don't get confused. Like, don't accidentally plug it into the derivative. We're plugging it into the OG original function. So you're going to take 0, you're going to plug it in here. 0 to the 4th power is 0, minus 8 times 0 squared. That's just going to give us 0. So I know that one critical point is 0, comma 0. For your next critical point, you're going to take 2, you're going to plug it in, use a calculator, you'll get a number, then you'll do negative 2. I feel like 2 and negative 2 are going to give us something the same. So instead of me showing you actually plugging in, okay, got it. Okay, so instead of me actually showing you, does anyone want to see how so basically all I did is when I plugged in 0 into the original, I got 0. That's critical point number 1. Then I plugged in 2 into my original. So again, these are getting plugged into your original function up here. And you're getting the output. So when I plugged in 2, the next one here, this one, I got negative 16. Then I had to plug in my last critical number into my original function, and I also got the same output, negative 16. These are all 3 of my critical points. That means at these critical points on my function, it's possible that we have a maximum or a minimum. We don't know yet. We're gonna have to test them out later, but this lesson right here is just how to get the critical points. Let's pause for questions. So that's the end of it. We got our critical points. That's all we had to do for this one. Pause for questions. And again, I'll be sharing with you a factoring tool that will be useful just in case if you get tripped up here. If you get tripped up here, I have a tool that can help you. Otherwise, if everything else makes sense, we're in good track. We're in a good progress. So I'll just pause to see if anyone has questions about the process or anything like that. And then I know sometimes a question will come up later, so that's okay. So while maybe you're thinking about questions, if you haven't already done so, if you'd like to take a screenshot to kind of add it to your like notes or something, I would do that. Like you could take a screenshot and just insert it into your own copy of the notes. And that way you have all the work that I kind of showed you as well. So that's just an option. So let me just pause if anyone needs to take a screenshot or anything, if they're doing like, virtual notes here. And then I'm gonna show you all the factoring tool that I found. This is great, yay. We have someone getting it, we have Rosa getting it, that's awesome. Okay, so I'm gonna start to clear my screen, everyone. Stop me if you need me to. There's something in the chat. Yeah, math is fun when you understand it, that's true. Yeah, when you don't understand it, you feel like you're in a country and everyone's speaking a language you don't understand, like a different country. So I know what you mean. That was me in college math. So, all right, y'all. So the factoring tool I'd like to share with y'all, just because I don't want you to get, I don't want you to get tripped up with a skill that's from a prior class. So I put it down here. For those who are following along with me on the slides, right in the notes section on slide number 9, it says factoring tool. So I'm going to also just put this in the chat so y'all can look at it. You could use it. When the AP exam, if you're still allowed to, if you're still allowed to take the AP exam on your computer, hey, use the tool. Don't waste your time factoring. So here's how it works. So the equation we had to factor was x to the 4th power. I had to do a caret symbol to go up there like this. And then it was minus 2x, right? That was the thing we were asked to wait. It was it? No. We had to factor the derivative. So what was it? Let me go back. We had to factor this. So 4x third minus 16x. So go back here. Don't want to confuse you guys. 4x third minus 16x. That's what we were asked to factor. Again, this tool is limiting. I'll say this. The tool is limiting because it only works if you have like whole numbers. It won't give you like the solutions if it's like a decimal. So that's just something to keep in mind. Luckily though, if we click calculate, take a look. It factored it for us. So if you're looking for a time saver, I would totally use this if I don't want to waste my time, like on the test factoring, you could use this tool. Again, that's if we're still online. So that could be an awesome thing to do. Again, that's so that you don't get tripped up in the factoring part. Let me know if anyone has questions about that. And, or, hey, if you like to do factoring and you want to check your work, you can use the tool too. Cool. All right, so if no one has any questions on this, don't worry, they might come up because I'm going to have you right now process check. So we're going to be having our first participation segment right now. Padlet process check. Right now, I'd like you to just pause and reflect on the example we just did. Which part/step of the process was challenging? Which part of the process is clear to you? What questions do you have about the process for finding critical points? Let me go ahead and again, I'll copy down the palette, but if you're following along, it's usually whenever we have it, a process check, it will be here down in the notes section. So there we go. Let me plop that back in. But yeah, I recommend just have the palette open usually if we're in math class. And we are in column number 6 and they're labeled now. So you're gonna have to like scroll. So for example, there's like a little bar. I just, I just scroll like this using my, I don't know what you call it, the finger pad. I don't really use this bar down here. So we're on column number 6. I want you to, again, take a look at what we just did, the process of finding critical points. This is the technical process, right? So we should have a little bit of background about what are critical points, how can they help us when it comes to functions. But now it's like, let's go ahead and process the actual technical portion, which is the actual math part. And you're going to answer which step / part of the process was challenging or challenging at first, and which part of the process is clear. Oopsie, number 7. I see somebody typing out typing out number 7. Number 6 is the column that we're at. Number 6. Awesome, awesome. All right, number 6, and I'll give you all a minute or two. I'm gonna go ahead and put the directions back into the chat so we know what we're doing. All right. Make sure if because I'm seeing that um I don't see any more typing, but if you're still typing, please make sure to get your post in so I could give you credit. Again, we want to make sure we're fully engaging in the concepts and so forth, understanding the steps and the whys. So a common theme I saw coming up was the factoring part, and I was anticipating that. Yeah, it's been a while since we factored. And another thing that I thought about is that in the real world, right? Like if you're an engineer or whatever you are, right? I mean, you're not spending your time factoring, that's for sure. Usually, they mathematicians and applied mathematicians have tools to do that for them, and so what we need to understand is the concept, not really how to factor. So that's why I was pro you all using this tool. If it's like, yes, practice your factoring, yes, but don't let that hinder your understanding of the calculus that's going on, for sure. So just as like a little a note on that. So don't feel bad if you need more practice, because I would for surely. It's been actually quite a while since we've done that. I noticed that again. Yeah, factoring came up a lot. um in general though, it says the steps were clear. And then the box method, yeah. So that was the method I taught factoring, I think, for pre-calculus throughout these years. Uh, some schools probably done it differently. Some do it trial and error. There's different ways you can actually factor. So that's okay if the box was confusing. Okay, box method was really clear for someone else. Okay, so this one's new. So like the last part where we plug in, are we plugging in the whole equation or just part of it? I could totally answer that in a second. Let's see. Common term, the right order. I think setting each multiple zero is the easiest. And then the question would be here, would there be fractions involved? I would only encourage you to do fractions if you're there. If your understanding is there, go for it. I don't think I'll be putting fractions, but if we do it, don't worry, I'll talk about it, but I don't think so. For this part, no. Okay, factoring is just a common theme. So that's okay. So yeah, let me go back to that question about the plugging back in to get your critical points. So the question was, do we plug it into the whole function or just part of the function? So you want to plug it into the whole function. So let me, for example, show you how we got, like, for example, when I plugged in 2 to get this critical point, the middle one, how did I get how did I get positive 16? So you have to look at your original function, the OG function, and we're going to plug in 2 fully. So parentheses 2 to the fourth minus 8 parentheses 2 squared. So you notice how the 2 got plugged in fully to the whole function. After that, it's some PEMDAS. So first off, 2 to the fourth power, use a calculator, or you could do it in your head. 2 times 2 times 2 times 2, 4 times. 2 times 2 is 4, times 2 is 8. So I think that's 16. Minus, and this one you might have to be careful, PEMDAS, exponents first. You have to do 2 squared first. 2 times 2 is 4. So it's going to be 8 times 4. Wait, do you really get negative for this one? Oh, yeah, you do. Okay, I thought you get a positive. All right, so then you have 16 minus 8 times 4 is 32. So 16 minus 32, that will equal negative 16. So I just showed, for example, how we got this middle critical point. The process will be the same for each other one. So you would just plug in 0 fully into your original function. This one you'll plug in negative 2 fully into your original function. Cool. Let me know if there's any additional questions on that, but I definitely want to address that and make sure I made that part clear. All right, let me up. Thank you for your engagement. All right, let me go back to the slides. And we're going to do, it looks like we're going to do one more example. And then we're going to do an exit. So it looks like I don't think we're going to get to the first derivative test. That's okay. Like I said, y'all can take a look at that, and we're going to talk about it on Monday. That's okay. I think Monday, yeah. Okay, let's do just one more to get a little bit more of the hang of the process of finding critical points. So I'm on slide 11 right now in our notes or in our slides. And let's say I want to find all the critical points of this function. F of x equals x squared minus 4x. I really love this function because you're going to see we have less steps. Step 1, take the derivative. Boom. That is the derivative of that function. And again, that's why I want to stress, do the Khan Academy practice tonight or today or right after this class, because you're going to get some refresher on how to quickly take, the derivatives using the power rule. Just get that practice in, will be really helpful. So step 1, take the derivative. Step 2, set the derivative equal to 0. Remember why we're doing this, because when the derivative is 0, it's a possible maximum or minimum. Super important. Next is usually we factor. The problem is you actually can't factor 2x minus 4. It's kind of already factored. I mean, you could if you want to pull out a 2, but you don't have to. All we got to do is solve for x here, and we could do that already. So solve for x solution. So notice how I didn't have to factor in this problem. There's no need for it. So it's kind of easier. So I'm like, oh wait, we don't got to do that step. Let's skip it then to the next step. Solve for all x solutions. Well, all we got to do is, it already gave us the answer, but let me just make sure I make it clear what we did. So to solve for x, you just add 4 to both sides. You're going to get 4 equals 2x. And in order to solve for x, you have to do the opposite of multiplication because this is 2 times x. So we're going to divide by 2. And 4 divided by 2 is simply 2. So x is going to be equal to 2. And it's right here. Just wanted to make sure I explained it. And again, once we solved for x and you have a number like x equals blah, that's called a critical number, not a critical point. It's called a critical number. It's important to know that distinction. Critical point is when you take the critical number, plug it back into your original function. I'm going to try to clear this so this one's kind of nicer, right? I kind of did the example first. Take this, plug into your original fully. That means for this x and for this x. So all x's in your function. And in this case, we're only going to get one critical point because there is only one critical number. All the critical points here is just going to be at 2 comma negative 4. So you could check it. If you plug in 2 into your original function, you should get negative 4. Double check it though. I might have had an error, so you could double check that. And I put a little note here. If we can solve without factoring, then that's great. We got less work. And let's see, does anyone have questions about example 2? All right. I mean, so far no questions, but I understand that sometimes questions might come up as you continue to ponder it, and that's okay. Let me just check out. Yeah, so then the last thing we're going to do is we're going to go back to the Padlet, and now we're going to formally, now we're done with knowing what critical points are. We're done with our practice on that. And then for next week, we're going to transition into what is the first derivative test. Feel free though, for any of you who are ready to like take a look at what's to come, to go ahead on the slides. So the closing question is back on the Padlet, y'all. Let's see what our closing question is. Again, I'm gonna just put this back in case you You closed up that Padlet. And, oh, hey, okay. Let's just go where Roxana's at. What happened to my, okay. Yes, what's one thing you learned today? Let me just move this over. I'm going to make this one number 8. This one's going to be number 7. Y'all know what to do now. Thank you. Yay. Okay, let's just close out on critical points. What is one thing you learned today? Please make sure that you complete this. Both checkouts or check-ins and checkouts, number 6 and number 7, column today for a credit. Again, your initial or name to see what y'all learned today. Awesome, awesome. Go ahead and take a minute there. All right, so these are great. So a common theme I see popping up is knowing and learning what critical points are. Um, Relearning box method. Another one was, there was another one. Skip the factoring if there's nothing really to factor out. Yeah, so like kind of like make your own judgment when it comes to following math steps. Um, but yeah, that's awesome learning, y'all. And then, oh yes, another theme that popped up was that I think twice, two of you said something about you already kind of know how to do that, the kind of math that we're doing. Like we know how to factor, we know how to solve for X, but now it's on the goal of finding critical points. So that was interesting and awesome that we learned it. All right, y'all. Thank you so much for your checkout. Again, feel free to like look ahead, but we're going to be doing the first derivative test on Monday. Y'all have a great, what is it? It's not, I don't know if y'all are going to have an early lunch or, oh, no, it's your next class, huh? Yeah, okay. I'll let y'all go because I think period 5 is starting. Bye, everyone. Enjoy. Thank you so much for your hard work. Bye. Bye, everyone.